Now let's do carbon. This is more interesting now. Remember, how many Slater determinants we say we could write for carbon? You have 1s, you have one electron in the 1s, spin up, one electron in the 1s, spin down. I'm just going to put a bar over that to indicate spin down. One electron in the 2s, spin up, one electron in the 2s, spin down, right? And then one electron in one of the 2p orbitals, let's say 2p plus 1, spin up, and another electron in a 2p plus 1 maybe spin down. That's one of many possibilities. In fact, there are 15 possibilities. Right? So this, you can write a Slater determinant for that, multiply that by 1 over square root of 6 factorial. Okay, so this is going to be a function of electron 1, electron 1, electron 1, electron 1, electron 1. You have the same set of spin orbitals, 1s, 1s bar, 2s, 2s bar, 2p plus 1, 2p plus 1 bar. And this second row will be a function of electron 2. Okay? And you expand this later determinant, you're going to get 6 factorial terms, right? So this is one of many Slater determinants that you can get. How many Slater determinants can you get? 6 factorial. 6 spin orbitals. P plus 1, P plus 1 bar, P0, P0 bar, P negative 1, and P negative 1 bar. 6 possible spin orbitals, okay, and you have to assign 2 electrons to them. So 6 spin orbitals taken 2 at a time. Number of combinations would be 6 factorial divided by 2 factorial times 6 minus 2 factorial, which would be 6 times 5 times 4 factorial over 2 factorial, 4 factorial. 4 factorial cancels out. That gives you 30 over 2. That's 15 possible Slater determinants you can write. So what are the terms? What linear combinations of those 15? Okay, if you take linear combinations of those 15, you're going to get terms. What are the terms that we're going to get? Let's see. All we have to do is list all of those possibilities, figure out the M sub L, the total M sub L for each one of those, okay? And keep in mind that M sub L's always come as a set from L to negative L, and also list all the M sub S's. And keep in mind that your M sub S's always come as a set from S to negative S. All right, so let's do that. And we're just going to ignore the 1s2, 2s2 part because all of these will just cancel each other out. That will just give you a total of 0 contribution to your M sub L and M sub S. So we're just going to look at the P. Okay, so you have 2p plus 1, 2p plus 1 bar, 2p minus 1, 2p0, 2p0 bar, 2p minus 1, 2p minus 1 bar, and then we're going to have M sub L and M sub S. Okay, let's look at the possibilities again. Okay. You can have one electron here and another electron in the 2p plus 1 bar. Okay. What's M sub L for that one? The big M sub L is M sub M1 plus M2. What is M1? Plus 1. M2 is plus 1. So big M sub L is 2. The z components of your angular momentum would be h bar and h bar. So total z component is 2h bar. What's your M sub S? One electron is spin up, the other electron is spin down. So M sub S is 0. Okay? Let's look at the next possibility. You can have 2p plus 1 spin up. The other one could be 2p0 also spin up. What's our M sub L this time? Okay, so you're going to have plus 1 plus 0 is 1. What's our M sub S? Spin up, so plus 1/2, plus 1/2. Our M sub S is 1. Okay? Next one. 2p plus 1, 2p 0 bar. What's our m sub L for this case? So this is number 1, number 2, number 3. What's our m sub L? Plus 1 plus 0, so that's a 1. What's our m sub S? This is spin up, spin down, so m sub S is 0. Okay? Next one. 2p plus 1 and 2p negative 1. What's our m sub L? Plus 1 plus negative 1, m sub L is 0. Okay? And what's our m sub S? Spin up, 1. Okay? So let me fill this up completely. Let's look at all the possibilities. So we have this one right here. And then we'll take this pair, plus 1 and 2p plus 1 bar and 2p 0, and then 2p plus 1 bar, 2p 0 bar, and this possibility right here, and this possibility right here. Okay, let's figure out our m sub L and m sub S here. Okay, what's our m sub L for this one? Plus 1 plus negative 1, 0. This next one, plus 1 plus 0 is plus 1. The next one, plus 1 and 0, that's also a plus 1. The next one, plus 1 plus negative 1, this is 0. The next one is plus 1, negative 1, that's also 0. Let's look at our m sub S. This is spin up, spin down. M sub S is 0. This is spin down, spin up. M sub S is 0. This is spin down, negative 1/2 plus negative 1/2, negative 1. This is spin down, spin up, plus 1 plus negative 1/2, that is 0. This is spin, which one is this? This is spin down, negative 1. How many more do we have to go through? There's number 4, number 5, number 6, number 7, number 8, number 9. 6 more to go. So this time we're going to start with 2p 0. Right? That one, and that one. Okay, so this is 2p 0, 2p 0 bar, 2p negative 1, 2p negative 1 bar. All right, so what's our m sub L for this next one? 0 plus 0, 0. What's m sub L for the next one? 0 plus negative 1, negative 1. And what's m sub L for the next one? 0 plus negative 1 is negative 1. Okay. What's our m sub S? Spin up, spin down. Total m sub S is 0. Spin up, plus 1. Okay. Spin up, spin down, 0. So that takes care of number 10, number 11, number 12. How many more to go? 3 more to go. So this time we're going to do 2p 0 bar, 2p minus 1, 2p 0 bar, 2p negative 1, and finally the last one would be 2p 1, 2p negative 1, 2p negative 1 bar. What's our m sub L for this next one? 0 plus negative 1. I'm sorry, 0 plus negative 1. Negative 1. And then you have 0 plus negative 1. This is also -1. The last one is -1 plus -1 is -2. Let's look at the total spins. Spin up, spin down, 0. Spin up. I'm sorry, I got it wrong. All right. This is spin down, spin up. Okay, it's still 0. All right, so spin down, -1, and this spin up, spin down, it's going to be 0. Okay, so that's number 13, number 14, and number 15. So you have what's called 15 Slater determinants. You can call them microstates. Okay, 15 microstates. Those are your possible M sub L and M sub S values. Let's tabulate those. Let me see if I can put them all together in one spot. Okay, let me rewrite them here. Okay. So what do we have? Our M sub L, M sub S values. Okay, so you have a 2, 0. You have a 1, 1, 1, 0, 0, 1, 0, 0. Takes care of 1, 2, 3, 4, 5. And then the next one, and let me just copy that. 1, 1, 0, 0, 0. Okay. 1, 1, 0, 0, 0. And then you have 0, -1, 0, -1, 0. 0, -1, 0, -1, 0. Okay, so that's 5, there's another 5, and then the last 5 would be 4 -1s and a -2. Okay. -1, -1, -1, -1, -2, and the M sub S's for those are, let me see if we get that one right. 1, 0, 0, -1, 0. 1, 0, 0, -1, 0. Did I have everything right? Okay. All right. So, hopefully I didn't miss anything. Otherwise, we're going to hit a dead end. All right. What is the largest M sub L value? Among these M sub L values that we have here, what's the largest one that you see? 2. So that must be part of a set for L equals 2, right? M sub L equals 2, 1, 0, -1, -2. Okay. For M sub L equals 2, what is the largest M sub S? There's only one. Okay. The M sub S is 0, right? That means for this M sub L equals 2, the M sub S that corresponds to that is 0. There is no other possible M sub S. So what must be the S that's associated with this? S, that must be for S equals 0. You cannot have any other S other than for this that was associated with M sub L equals 2 other than S equals 0. So what is the term that corresponds to this? L equals 2 is what term? It's a D term. What's our multiplicity? What is 2 times 0 plus 1? Singlet D. So this will correspond to this. 2, 0, we'll take care of that. And then you have a 1, 0. So pick any one of those 1, 0. It doesn't matter which one you pick. And then 0, 0. Let's get rid of a 0, 0. And then you have a -1, 0. There's a -1, 0 right there. And then -2, 0. Okay? That takes care of 5 quantum states, 5 microstates. A singlet D has a degeneracy of 5. There's 5 wave functions associated with that. Okay? What's next? Look at the remaining M sub L. So what's the largest remaining M sub L? 1, right? That means the next term, you'll have a term that has an L equal to 1, because that has to be part of a set that goes from +1 to -1. So the next L that you have, the next largest M sub L you have is 1. So that must be part of a set that goes from 1, 0, -1. So that's L equals 1. What kind of term is that? What's this term symbol? It's a P term, right? All right. Look at your L equals 1. What's the highest? What is the highest M sub S that's associated with M sub L equals 1? 1, right? 1, 1. So that means that M sub S must be part of a set that goes from M sub S equals 1 to -1. So there must be an S that's equal to 1, right? So associated with a P term is an S term which is equal to 1. This accounts for, what's our degeneracy then? M sub S would be 1, 0, -1. What's our multiplicity? 2s plus 1 is equal to 3. The degeneracy is multiplied by 3 because of the spin, so you have a triplet P term. How many quantum states does this account for? 3 times 3, this accounts for 9 states, right? So let's get rid of all of these now. So that's 9 states. Your singlet D accounts for 5 states. So what are those 9 states? Okay, 1, 1. 1, 0. Where's 1, 0? Right there. 1, -1. Okay, and that takes care of 3. That's for M sub L equals 1. Let's do M sub L equals 0. So you have 0, 1, 0, -0, 0, and 0, -1. That's another 3, right? And then you have -1, M sub L equals -1, M sub S equals 1, -1, 1, -1, 0, and -1, -1. That takes care of the other 3. So that takes care of all 9 possible quantum states. So your M sub L 1, 0, 1, and your M sub S would be 1, 0, -1. Okay, so you have 1, 1, 1, 0, 1, -1. Oops, the other way. This is M sub L, that's M sub S. 0, 1, 0, 0, 0, -1. And then you have -1, 1, -1, 0, and -1, -1. That takes care of 9. How many states do we have remaining? 1 more. Okay, we struck out everything else except the 0, 0. So that would be what? L equals 0. What's L equals 0? What kind of term would that be? So the last remaining term would be an S term, L equals 0, and S must be equal to 0 because your M sub S can only be 0 for that one. What's the multiplicity if S is 0? 1, you have a singlet. Singlet S, triplet P, and singlet D. Okay? So your 15 electron configuration associated with carbon, the ground state of carbon, has 15, there's 15 ways you can have that electron configuration. At a higher level of accuracy, if you take into account electron-electron repulsion more fully, you'll find that that degeneracy is going to split into 3 terms. Okay? A triplet P, a singlet D, and a singlet S. Okay? The triplet P term is going to have 9 Quantum states. So what are those quantum states? It's not any one of these Slater determinants. It's linear combinations of these Slater determinants. That's why we didn't care which of these combinations we pick. Okay.